400. I mean, just take a second to let that number really sink in. SpaceX recently hit a truly staggering milestone, landing a Falcon 9 first-stage booster for the 400th time. It happened during their Transporter 13 Rideshare mission, and honestly, it perfectly highlights the sheer scale, speed, and reliability of modern spaceflight. Accessing space isn't just this rare, monumental event anymore, right? It's basically become a routine delivery service. But that brings up a great question. What exactly are they delivering? Well, that's where this story gets really fun.
Welcome to This Explainer. I am so thrilled you're here. Today, we're diving into the fascinating dynamic of the modern space rideshare industry. We're going to explore a total revolution in how we access orbit, one that relies on some of the largest, most powerful machines ever built by humans, all working to deliver spacecraft that can literally fit right in the palm of your hand. Here is a quick roadmap for today's explainer. We'll start off with the space rideshare boom, then check out some massive rockets and helicopters in Section 2. Next, we'll zoom way in for the PocketQube revolution before looking at Alba Orbital's tiny empire, and we'll wrap the whole thing up with big data from small space. Okay, let's jump right in. Section 1. The space rideshare boom. How getting to space became a massive group trip. Let's think about the number 131 for a second. Historically, launching a rocket has been insanely expensive, but treating a rocket like a massive cosmic bus totally solves that problem. During the SpaceX Transporter 12 mission, a single launch basically split the bill and deployed 131 distinct payloads into orbit. I mean, the cargo ranged from a massive 750-kilogram high-resolution optical satellite from the UAE all the way down to little Peko satellites weighing less than a single kilogram. Suddenly, space is accessible to universities, tiny startups, and smaller nations who could never, ever afford a dedicated launch on their own.
And this really shows off our brilliant new orbital ecosystem. You've got mega constellations, like the thousands of Starlink satellites giving us space internet, launching constantly. But right alongside them, we've got these rideshare missions using something called orbital transfer vehicles, or OTVs. You can kind of think of these like specialized space tugs or even local delivery trucks. Companies like D-Orbit with their Ion vehicle or Impulse Space with their Mir vehicle ride the big rocket to space. Then, these OTVs detach and carry clusters of smaller satellites that last mile to their precise final destinations in orbit.
Section 2. Rockets, helicopters, and records. The spectacular scale of modern delivery vehicles. A perfect example of this massive scale is Rocket Lab. Let's just walk through the absolutely wild sequence from their 26th mission, which they very aptly named There and Back Again. First, their Electron rocket launches 34 satellites to orbit. Second, the first stage booster comes back to Earth, surviving the insane heat of re-entry and pops its parachutes to slow down. Third, and this is the completely crazy part, Rocket Lab actually had a Sikorsky S-92 helicopter waiting at 6,500 feet to rendezvous with the falling booster and catch the parachute line with a hook. Now, ultimately, the pilot noticed a weird load characteristic and safely dropped it for a controlled ocean splashdown. But the sheer ambition of the catch is mind-blowing. I absolutely love this quote from Rocket Lab's founder and CEO, Peter Beck. He said, "Bringing a rocket back from space and catching it with a helicopter is something of a supersonic ballet." It really hits the nail on the head. Think about the crazy scale we're talking about here. An 8-ton payload-class launch vehicle, roaring to the very edge of space, and then floating back down to be caught by a helicopter in midair. It's a highly orchestrated, massive engineering marvel. Section 3. The PocketQube revolution. Zooming in on the incredibly tiny payloads. Okay, so what exactly is this supersonic ballet delivering? We just talked about giant 8-ton rockets and mid-air helicopter catches. By staggering contrast, a PocketQube is a miniaturized satellite format measuring just 5 centimeters cubed. That's right, 5 by 5 by 5 centimeters. This base unit is known in the industry as a 1P size. We have literally gone from massive multi-ton machines that need whole maritime fleets to recover them, straight down to a fully functional spacecraft that you can just casually hold in one hand. It is a stunning contrast. To kind of help visualize how this tiny tech scales up, let's compare two platforms from a company called Alba Orbital. On one hand, you have their Unicorn 1 platform, which is that standard 1P format, the perfect 5-centimeter cube. On the other hand, you have the Unicorn 2 platform, which steps it up to a 3P format. It's still just 5 by 5 centimeters wide, but it's 15 centimeters long. So a little bigger, but that slightly larger size lets them pack in much more advanced sensors while still staying unbelievably tiny compared to your traditional old-school satellites. Section 4, Alba Orbital's tiny empire. How a Scottish startup became a leading microsatellite broker. If you trace Alba Orbital's journey, you really see a masterclass in this micro-revolution. Tom Walkinshaw founded the company back in 2012 in Glasgow, setting out to totally master the PocketQube format. Fast forward to 2021, they're participating in the prestigious Y Combinator Accelerator in Silicon Valley and pulling in $3.4 million in funding. And by 2025, they aren't just building neat hardware anymore. They are actively publishing Earth observation images collected by their very own Uniform 2 satellite constellation in orbit. They've essentially built an end-to-end tiny empire. But here's the really smart part. They don't just launch their own stuff. They act as a rideshare broker for other tiny satellites too. They've successfully integrated what they call Alba clusters onto major launch vehicles. Back in December 2019, Alba Cluster 2 flew on a Rocket Lab Electron. Then they bumped up to the massive SpaceX Falcon 9 for Alba Cluster 3 in 2022, and they've got Alba Cluster 12 slated for 2026. Basically, they're gathering up all these tiny payloads from universities and startups all over the globe and buying bulk space on the big rockets. Now, you might be wondering, how on earth do you safely attach a bunch of 5-centimeter cubes to a roaring SpaceX rocket? Well, the answer is the AlbaPod deployer. Alba Orbital actually manufactures this crucial piece of hardware themselves. It acts as a physical bridge, securely holding up to 96 PocketQubes, packed safely inside its protective shell. It keeps them totally secure during the incredibly violent, shaky rocket launch, and then systematically deploys them once they finally reach the calm of orbit. Section 5. Big data from small space. The impact of a democratized orbit. So we've seen how they do all of this, but we really need to ask the critical question, why go so incredibly small? I mean, what is the actual practical point of launching a 5-centimeter satellite? Are these just neat little toys for engineers, or do they actually matter? The answer is they matter immensely. These tiny, democratized satellites are performing some seriously heavy-lifting missions right now. First off, Earth observation imaging, like Alba's Unicorn constellation, constantly monitoring the globe. They're also monitoring global light pollution, which was actually a specific payload on a recent Rocket Lab launch. Plus, they are actively testing out technologies to track and remove space debris, which is absolutely vital as our orbits get more and more crowded. And finally, maritime surveillance and IoT connectivity. Startups are literally tracking ships at sea and providing data networks from spacecraft barely bigger than a coffee cup. These tiny tools are doing highly complex, world-changing work that totally rivals traditional massive spacecraft. Which leaves us with this final thought. We are living in an era where catching a ride to space is basically a routine bus route, and the hardware required to do real hard science has shrunk down to the size of a literal paperweight. So, as these 5-centimeter cubes launch by the hundreds, what new world-changing ideas will fit right in the palm of your hand tomorrow? The barrier to entry to the stars has literally never been lower, and the potential has never been higher. Thanks so much for joining me for this explainer, and I'll catch you next time.